In this video, I'll be discussing 5 more interesting problems from signals and systems. These problems will be really difficult one. If you have clear concepts on signals and system, then you will find the solutions easy. Otherwise, you may face difficulty to understand the solutions. So if you feel any difficulty to understand this lecture, then I'll advise you to go through my previous lectures and then follow this video. Now let us start our first problem. The problem is given here. Let us consider one signal xt. So this is a signal mentioned. It is -1 whole to the power k del t minus k upon 200 and its summation. So this is one series of impulse signals, but its alternative. One time with k equal to 0 it is 1, then k equal to 1 it is -1, then again +1, again -1, like that. So amplitude is either multiplied by 1 or -1 with impulse signal, and that impulse signal is at k upon 200 and k is integers. Okay, so this is one periodic signal, right? This periodic signal is now passed through an LTI system with frequency response given as this one. This is the h of omega of the system. This is flat between -500 pi to +500 pi. Now the Fourier series representation of the output is given as the output signal yt and its Fourier series representation. So output will be periodic. So if the signal is periodic to a system, the output is also periodic, and that periodic signal is Fourier series representation. There are 4 choices given. Now we need to find out the correct answer. I hope you have got the problem. So read the problem carefully. Try to solve this one by yourself. Can you solve it? It is really a difficult problem, and we need to find out the solution of this problem. We need to understand how to find the Fourier coefficients, Fourier series coefficients of periodic signals. And then when a signal is passing through a system, then what is happening? So all those concepts will be useful. So we'll be discussing everything. So please flow. Now this is our system. H of t we have considered. The signal xt is applied to the system and output is yt, and xt is given as this one, and the impulse response of the system is given as this one, right? As I said that xt is a periodic signal because it will repeat. For every k you will have one impulse. Okay, so first we need to understand that signal clearly. So with k equal to 0, you can understand that it is simply delta t, means I have one impulse signal del t at t equal to 0 with k equals to 0 here. Then if I consider k equal to 1, then it is minus del t minus 1 upon 200. Meaning is the amplitude is -1, so means minus del function, and it is located at 1 upon 200. So at t equals to 1 upon 200, there is an impulse and its amplitude is negative, minus del. So delta function located as 1 upon 200 and amplitude is negative. Then if I consider k equal to 2, again it will become positive, and that time the position is 2 upon 200. So at 2 upon 200 again we will get one more impulse, del t. Similarly, left hand side minus 1 upon 200 is minus del function, and at minus 2 upon 200 again positive impulse. So thus this signal will repeat and we will get one periodic signal. Okay, so this is the periodic signal, and time period, we can understand that this signal will come repeat here after 2 by 200 means 1 upon 100 second, means 1 millisecond. So time period for this periodic signal is 1 millisecond. Now we need to find out Fourier series coefficient for this signal. And as it is given in trigonometric form, the choices are given. So we'll try to find out trigonometric Fourier series coefficients. In trigonometric form, the x of t, this periodic signal, we can replace as, or we can express as 1 dc a0 plus AC components an cos n omega naught t plus bn sin n omega naught t, this summation for all integer n equal to 1 to infinity, where omega naught is your angular frequency 2 pi upon t naught, and t naught is already we have computed, it is 1 millisecond 1 upon 100. Thus omega naught is 200 pi and unit is radian per second. Clear? So this is your omega naught and this is your Fourier series expansion. We need to find out these coefficients a0, an and bn, right? Now xt, it shows clearly that it is an even function because at negative side and positive side it's symmetrical. At minus 1 upon 200 I have one impulse. Similarly I have one impulse at plus 1 upon 200. Again minus 2 upon 200 I have one positive impulse. Again similarly I'll have at plus 2 upon 200 another positive impulse. So this left and right hand side and left hand side is symmetrical, exactly same. Thus it is an even function, and for even function this Vn part is 0. The coefficient of sine term is 0. Okay, that is one property is there. So we can easily show that, so if signal is even, then it cannot contain any sine function because sine is an odd function. Okay, so even function can be expressed by summation of even functions. And a0 is DC even, and an cos n omega t, these all are even function. And but sine is an odd function, thus the Vn terms should be 0 for all n. So no need to consider any Vn, right? Now the signal can have a0 and an. Now a0 is given by 1 upon t0 and integration of xt over one time period t0 or t0. Okay, so this t0 or t0, this is a fundamental time period. This is 1 millisecond here. So we need to integrate for any one time period. So to avoid the confusion, we'll consider starting point here minus t1 to t2. So this gap is again 1 millisecond. We'll consider. So this total 0 to t1 plus 0 to t2. This total t1 plus t2 equals to t0. Okay. So this range I will consider minus t1 to t2, and then xt within one fundamental time period, the signal is having two impulses, one at 0, that is your del of t, and another one is at t equals to 1 upon 200, but the amplitude is minus 1, thus is minus del t minus 1 upon 200. So try to understand this thing, because we are considering one signal xt periodic, but within one time period we need to integrate the signal xt. So within that minus t1 to t2, I have two impulses. One is positive impulse located at 0, another negative impulse located at 1 upon 200. Okay, so this is your del t here, and this is your minus del t minus 1 upon 200. Okay, and so now we need to integrate this function, and that is very easy. Now we can separate these two things. So we can integrate only del first terms, del t, and then again we can integrate second one, and integration of del t is 1 if it includes the function del t. Within this range minus t1 to t2, the signal del t is present. Thus, area under del t curve is always 1. Okay, and again here within this one, this function is also existing. Okay, so this function is located here. So within this range, this function is also del function, and its area is again 1. Thus this is 1, this is again 1. So 1 minus 1 is 0. Thus H0 is 0. Okay, I think you understand the properties of impulse signal, unit impulse. So area under the unit impulse is always 1 if signal is present within the range. Okay, so range I have considered minus t1 to t2. Within that one, del t is present here. So area under this curve is 1. Again, similarly, within this range, this impulse is there. Thus, for this one, again its impulse value, area, is again 1. Thus, 1 minus 1 is 0. So H0 is 0. Next, we need to find out AN. And AN is given as 2 upon T0 and integration of xt times cos n omega naught t dt. Right? And we need to integrate it over one time period, any one time period. So I'll consider this thing in the same way. So this is 2 upon T0 and limit I'll consider minus T1 to T2 and xt is replaced by del t minus 1 upon 200. Okay, and we'll multiply cos n omega naught t and then we'll integrate. Now we can separate these two terms. The first term is becoming del t times cos n omega naught t dt, and second term is del t minus 1 upon 200 times cos n omega naught t dt. So individually we need to compute the integral for these two terms, and this is easy one. So what you will do, if any signal, any gt function is multiplied with del t minus tau, then we can replace this one by g of tau times del t minus tau, because del t minus tau will exist at t equal to tau only, and that time its value is g of tau, and that value is multiplied with impulse. So this resulting signal is again impulse, but amplitude is modified by this factor g of tau. Okay, this is useful because this signal, time domain signal, is now becoming again simply an impulse, but this is a constant independent of t. T is replaced by tau here, g of tau. So in the integral we can take it outside because integration is with respect to t. Now same thing I have used here. So this del t cos n omega naught t, this I can replace by del t times cos of 0, because here tau equals to 0. So cos of 0, that cos of 0 I can take outside. Okay, so cos of 0 is independent of t, I have taken outside, and so integration is only del t dt for limit minus t1 to t 2. It should be 2. Okay, fine. Next term, this one. So this again it's a product, but this function is located at t equals to 1 upon 200. Okay, so tau is here 1 upon 200. Thus here it is cos n omega naught t. I replace t by 1 upon 200. So it will become cos of n omega naught by 200, and that term is independent of t, it will come outside. I write cos n omega naught times 1 upon 200, that is outside, and then I can integrate only these things, del t minus 1 upon 200 times dt. Now it is very simple, because the integration of del t is always 1, this is also 1, and this is also 1. That already we have discussed. Okay, now cos of 0 is 1, and cos of this one, n omega naught by 200, that we need to compute, and we will continue. So first one, so this is your 2 upon t naught outside scaling factor, and this cos omega naught is 1, cos 0, sorry, cos 0 is 1, and this integration of del t is 1, because within this range del t will exist. And now cos n omega naught upon 200, and you know that omega naught is 200 pi. If you replace omega naught by 200 pi, then 200 will cancel. You will get only pi here and n here. So it is cos n pi, and this integral is 1. Okay, so it simplifies to this one, 2 upon t naught times 1 minus, and this cos n pi we can write minus 1 whole to the power n, because cos 0 is 1 and cos phi is minus 1, cos 2 pi is 1, cos 3 pi is minus 1. So it is alternating 1 minus 1, 1 minus 1, like that. So it is minus 1 whole to the power n. So when n is odd, it is minus 1. Now when n is even, it is plus 1. Right? So I can write that for n even n, when n is even, that time it is 1. 1 minus 1 is 0. This value is 0. And for odd n, this value is minus 1. So 1 minus minus 1 means this is becoming 2, and 2 and 2 is 4 by t naught. So this value is 4 upon t naught, and t naught is 1 millisecond. Thus this is 400, or not 4000. This is your 4000 for odd n. Means for n equal to 1 it is 4000, n equal to 3 it is 4000, n equal to 5 it is 4000, n equal to 7 it is 4000, like that. But for odd even, like 2, 4, 6, every time it is 0. So n we have computed, a naught we have got, it is 0, bn is also 0. Okay, so now we can find the Fourier series expansion of xt. So xt, a0 is 0, b0 is 0, and this an cos n omega naught t. An I have said for even it is 0, for odd it is 4 upon t naught, means 4 upon t naught is constant for every n, every even odd n, right? So that is your 400. So 400 I will take outside, and then for only odd, n equal to 1, n equal to 3, n equal to 5, all those things we'll consider, and omega naught I will consider 200 pi. Already you have seen omega naught is 200 pi. So 1 into 200 pi is cos 200 pi t. First one. Then it's 3 times cos 3 into 2000 pi t. So cos 6000 pi t. Okay. Then again cos 5 times of 2000 pi t means 10,000 pi t, like that. So these are all, and all signals will have the same amplitude, 4000, right? So this is your expansion, and this system response is given here, and it looks that it is your low pass filter 0 to 5000 pi. Here 5000 pi is the cutoff frequency. So any frequency, if it is within 0 to 5000 pi, it can pass through the system easily without any attenuation because amplitude is flat 1. But if the frequency is more than 5000, then that signal will be attenuated, and that signal will be have send at the output because amplitude will become 0. Okay, now we need to understand the frequency of these coefficients, of these components, so that we can show here. So first term is cos 2000 pi t. So this frequency is 2000 pi. So omega naught at omega equal to 2000 pi, there is one line, and its amplitude is 4000, right? Similarly, I'll have another spike at 6000 pi here, and 10,000 pi, like that. So more, even more. Similarly for negative side and left side also. Okay. So within this band, minus 5000 pi to plus 5000 pi, only this frequency will exist, 2000 pi, and that can pass through. So this signal can only pass through. This is attenuated, it cannot pass through. This is cannot pass through. All other higher frequency component cannot pass through the system because system is having low pass characteristics and cutoff frequency is 5000 pi. But only this component is having a frequency within 5000 pi, and frequency is 2000 pi. Okay, and amplitude is 4000. Thus output is simply 4000 cos 2000 pi t. So answer is C. Okay, I hope you have understood this problem, the solutions of this problem. And if you have faced any difficulty to understand this problem, I'll request you, please go through my lectures, previous lectures. You'll understand better. Now I'll go to the next problem. Before that, may I ask you that if you like this video, if you have enjoyed this video so far, can you press the like button? Because if you press the like button, then the video can reach to the more viewers, okay, and many people can get access of this video. So thanks for watching, and if you enjoyed, please press the like button. And now I'll continue the next problem. The next problem, the second problem, is this one. The ft is given as an even function, f of minus t equal to f of t for all t. Let Fourier transform of f of t is defined as this one. This is standard Fourier transform. F of w equals to f of t integration of f of t times e to the power minus j omega t dt for the range minus infinity to plus infinity. The standard definition of Fourier transform. Now it is given as the derivative of f of w with respect to W equals to minus W times f of W for all W. Okay, and f of 0, capital F of 0 is given as 1. And from this information, we need to find out f of 0, whether f of 0 is more than 1 or less than 1 or equals to 1 or equals to 0. Okay, this is the question. Now, can you solve this problem? You can pause here, you can try to solve this problem. Okay, so this is regarding Fourier transform. I have discussed Fourier transform in detail. So in one video, I have discussed all the properties of Fourier transform, and also I have discussed few typical problems from Fourier transform in detail. So you may go through that video as well. Now we'll try to solve this one. Now f of t, small f of t, time domain signal, its Fourier transform is capital F of W. Okay, and relation is given. Relation given here is df of W dW, derivative of f of W, equals to minus W times f of W. And it is also given that f of 0 equals to 1. So this differential equation we can solve. So we can consider that d of f of W upon f of W. This f of W I can take denominator here, and this one dW I can take here. Okay, so this is the function equation we will get. Now we can integrate both sides. So if I take integration, I'll get one integration constant C. Now this one is your ln f of W log base E f of W, and this integration of W is simply W square by 2. So it is minus W square by 2. And this integration constant C, I can take ln K, because whenever there is one ln part, okay, so if I take this constant as ln of K, then we'll combine these two. Okay, I can take this one in left side. So this is your ln f of W minus ln K, that I can combine ln f of W by K, and that is equals to minus W square by 2. So f of W equals to this K times, and this is your base is E, so it will become e to the power minus W square by 2. So this is K times exponential of minus omega square by 2. Right? So this is the function f of W. And one condition is already given. Capital F of 0 equals to 1, that I can use to find this K, constant K. So if I use this one, that W equal to 0, both side. So this one left side is f of 0, right side e to the power 0, this value is e to the power 0, and it is K, and e to the power 0 equal to 1, thus K equals to 1. So this K is becoming 1. Right? Now we'll consider this one, that area under f of W, this property is f of 0 equals to 1 upon 2 pi integration of capital F of W dW. Okay, this is very simple. So inverse Fourier transform, we can easily find it out. So here f of 0 is total area under this f of W, whose scale factor 1 upon 2 pi, and already we know this function f of W equals to e to the power minus omega square by 2. So we need to integrate this function. Okay, total area under this curve. So this in this area minus infinity to plus infinity e to the power minus omega square by 2 dw. This will be simply square root of 2 pi. Why? Because if I consider one probability function, density function, P of W, Gaussian probability density function, that is your e to the power minus omega square by 2 sigma square, then this factor is 1 upon square root 2 pi sigma square. It is becoming one Gaussian probability density function, and total probability is always 1. Integration of PW dW equals to 1. Okay, so area under these things, okay, this integration is 1, and right side integration, obviously this integral should be equals to square root 2 pi sigma square, right? So these things. So integration of e to the power minus omega square upon 2 sigma square d omega is square root 2 pi sigma square. And in this case, sigma square given as 1. Because if I compare this one, so sigma square is not there, it means sigma square is 1. So I can replace by sigma square 1. Thus it is square root 2 pi. So this value, integration value is square root 2 pi, that I can replace. So this is your function, and this function is square root 2 pi here, it's 1 upon 2 pi. So total is 1 upon square root 2 pi. And you know that this square root 2 pi, its value is more than 1 because pi is 3.14. So it is square root of 6 point something. So obviously it is less than 1. Right? So f of 0, small f of 0, time domain at t equal to 0, that signal should be less than 1. Okay, so the answer is A. I hope you have got this concept. Okay, and if you have any doubt, please write in comment section. We'll move to the next problem. Now next problem is regarding the discrete sequence x of n. X of n is considered given as half to the power n, 1n, and 1n is simply 0 if n less than 0, and 1n equals to 1 if n more than 0. Means this is your u of n, step sequence. Okay, this is simply step sequence. Left side is 0 and right side of n is always 1. Right? So this is the sequence given. Now z transform of x of n minus k is already given as z to the power minus k 1 minus half z to the power minus 1. This is your function, but we need to find out the region of convergence. So what is the region of convergence for this sequence, this z transform? Whether mod z equals less than 2 or mod z more than 2, mod z less than half, mod z more than half. Okay, so we need to find out this condition. It's a very simple problem. Okay, so let us solve this problem. The sequence is given as this one. This is half to the power n un. So if I consider this is your origin, at 0 it is 1, then half square, half 4, half cube, half to the power 4, like that. So this means this way. So this function is decreasing exponentially. Okay, and left side is 0. So this is the sequence. And z transform of x of n is very simple. That is defined as x of n times z to the power minus n. First take this product and then sum it up. Okay, so with 0, this one I'll multiply it by 1 because z to the power 0 is 1. Then for next one, half, I'll multiply z to the power minus 1. 1/4 z to the power minus 2. 1/8 z to the power minus 3, like that. Then I'll sum it up. And left side is 0 because all samples are zeros. right? So this is the sequence, and this sequence will converge. I can rewrite in this form: 1 plus half d to the minus 1. Second one is half d to the power minus 1, that square. Next one is again half d to the minus 1, that q. So this is your GP series: 1 plus a square plus a cube, like that. So that sequence will converge if the ratio, the R or A, the ratio is less than 1. Okay, so if I consider this ratio half z to the power minus 1, its absolute value means half mod of z to the power minus 1. If it is less than 1, then the sequence will converge. So this condition means mod z is more than half. So if I consider one circle here, so mod z equal to half means this is one circle with radius half, and mod z more than half means it is outside this circle. Any region, any point on this range, outside region, the sequence will converge. Okay, and value is 1 upon 1 minus r, means 1 minus half z to the power minus 1. Okay, so this is the z transform of xn only. Okay, but we need to find out x of n minus k, its z transform. Okay, now we need to understand whether the ROC will change or not for this shifting. Okay, so let us consider this one. So if it is shifted by k, the net kth element, its value will be 1. Then k plus 1 element, it will be half. Then 1/4, 1/8, like that. And up to this 0 to up to k minus 1, all will be placed by 0, replaced by 0. So sequence is shifted right side by k sample. So it will look like this. This is your x of n minus k. And its z transform is similar. So this is x of n minus k, z to the power minus n. That summation we need to consider. So with this one, I need to multiply with z to the power minus k, because it is a kth element, is 1, and z to the power minus k should be multiplied. Then half z to the power minus k minus 1, half 1/4 z to the power minus k minus 2, like that. Okay. Now z to the power minus k I can take outside common. Then again I will get the same sequence: 1 plus half z to the power minus 1, half z to the power minus 1, that square, like that. So same series, only z to the power minus k outside. So obviously we'll get the same condition for convergence. So I'll get this series value will be 1 upon half minus z to the power minus 1. So this is your, and multiplied by z to the power minus k, that is a z transform, is already given. And ROC should remain same as earlier, because this is the same series, meaning that this half z to the power minus 1, that mod value should be less than 1, meaning is that mod z should be more than half. So this is your result. So answer D is correct, right? So it's not a difficult problem. You can solve it. Now we'll move to the next problem. Now suppose for this problem it is given that, suppose for input x of t linear time invariant system with impulse response h of t, it produces output yt, and yt is a convolution between xt and h of t. Now further, if x mod of x of t convolution mod of h of t, this convolution is z of t, then which one is true? Okay, the for all t, z of t is less than y of t, or for some but not all, z of t is less than y of t. The third choice is given as z of t is more than y of t for all t, and fourth choice given z of t is more than y of t for some value but not for all. Okay, have you got the problem? Read the problem carefully. So it says that one input signal xt is applied to a LTI system, its impulse response h of t, and output is yt. That is one relation given. Now, it is saying that if mod of xt and mod of h of t, if we take the convolution between these two, and that convolution value is z of t, now we need to compare this z of t with this y of t, whether it is more than y of t or less than y of t, for all values or some values of t. Okay, now let us find it out. So y of t is convolution of x of t and h of t, because x of t is the input and h of t is the impulse response. If I take convolution between input signal and impulse response, I'll get the output. That is given by x of tau h of t minus tau d tau, its integral. Okay. Now mod, so a z of t is given as mod of x of t convolution with mod of h of t. So this convolution, if I consider, then it is this signal one x of tau, t replaced by tau, so mod of x of tau, and it is mod of h of t minus tau and d tau. And you can see both functions are mod, but here in above yt, x of tau, h of tau, there's no mod sign given. Okay, meaning is that this mod is always positive, same magnitude but positive. Here also sometimes the signal can be positive and negative, but here in this case always positive. So if I consider same function, same magnitude, but always positive, if I multiply these two, then if I integrate, so they will not cancel each others. Every time it will grow only. So you will get more area under the curve, because mod of x of tau and h of t minus tau, I can write that is equals to mod of x of tau h of t minus tau, and obviously it is more than x of tau h of t minus tau, because the magnitude will be same, but sometimes it could be negative. That's how it is more than that, right? So this z of t is always more than y of t for every t. There's no condition. Okay, for every t, z of t is more than y of t. It's a simple problem. Okay, now we'll move to next problem. This is our final problem for this video. It is again given a periodic function f of t and period of 2 pi. Its Fourier series is given like this, trigonometric form, a0 and summation of a n cos n omega a n t, b n sin n t, and f of t is a sin t for range 0 to pi and equal to 0 for pi to 2 pi. And for this Fourier, this function, we need to find out Fourier series a1 and b1 only, and choices are given here. So we need to find out Fourier series coefficient. That's all. So can you find Fourier series coefficient for this function, this f of t? Okay. So what is f of t? F of t is a sin t for the range 0 to 5, and 5 to 2 pi is 0. So this is your sine function 0 to 5, and 5 to 2 pi is 0. Again it will repeat. Okay. So this looks like half wave rectified signal, right? So if you know the Fourier series of half wave rectifier, then it is done. Here we will find the coefficients a1 and b1 for this half wave rectifier. This Fourier series trigonometric form is given here. I need to find a1 and b1. What is t0 in this case? T0 is this range, 0 to 2 pi, the time period, 2 pi. And omega naught is 2 pi by T naught, that means 1 radian per second. And H0 is 1 upon T0 integration of f of t. An is 2 upon T0 integration of ft cos n omega naught t. And Vn is 2 upon T0 ft times sine n omega naught t, its integral. That you know. Okay, we need to find out A1 and B1 only. So we'll go for that. So what is A1? A1 is 2 upon T0. So it is f of t. I'll put n equal to 1 here, cos omega naught t and dt. Okay, where omega naught is 1 radian per second, t naught is 2 pi. Okay, so ft I replace a sin t for range 0 to 2 pi. So here it is given two ranges, so I'll consider two range, 0 to pi and pi to 2 pi. For 0 to pi, f of t is a sin t, and phi to 2 pi it is 0. Okay, so the second part will become 0. So only that this range will consider. Okay, now this current factor is 1 upon pi. So this is right, this is a upon 2 pi. I'll consider 2 multiply here and 2 multiply here. So I'll get it is sine of 2t. The integration of sine of 2t due to pi, its value is 0, because 0 to pi it is double, frequency is double, just you will get a full wave here. So total area under the curve will become 0. Thus A1 will become 0. Okay, so this is, you see, 0 to pi here it is sine t after this one, and pi to 2 pi is 0. But if I consider sine 2t, then within this one I'll have a full cycle like this. So full cycle means sine wave, this total area under the sine curve is 0. Positive and negative area it will cancel. Okay, now B1 is similarly you can compute. It's 2 upon T0 ft sine omega naught t dt, and omega naught equals to 1 radian per second. So again, I'll consider two ranges. The second range will become 0. Okay, and first one is a sine t and again sine t. So a sine square t. Okay, so this a is outside, a by, and 2 I'll multiply here, a by 2 pi, it is 2 sine square t. 2 sine square t I can replace by 1 minus cos 2t. Okay, so two integral, one for integration 0 to pi dt only, other one is integration cos 2t dt. And this is again 0, because again same logic, I'll have a full cycle within 0 to pi of cos signal. And for this cos signal, total area positive negative will cancel, thus it will become 0. And integration of 0 to pi dt is pi only. So this is a by 2.2 pi into pi equals to a by 2. Okay, thus answer is a1 equal to 0 and b1 equals to a by 2. Answer D is correct. This one. I hope it is clear to all of you. Okay, if you have any question, please write in the comment section. Okay, and if you enjoyed this video, please press the like button. And if you have not subscribed the channel yet, you may subscribe this channel. I will be discussing more problems in this video. Thanks for watching.